So if a special case is something that only crosses one axis, what kind of lines do we have? Vertical or horizontal, right? Okay, so we're still dealing with graphing. And this is one of the more challenging concepts theoretically for freshmen. Okay? Okay. So special cases. Let's just go ahead and start with our examples. So for our first example, we're going to graph a horizontal line through 8, -2. Okay, horizontal line. So what's the first thing I need to do? Yeah, graph the point. You always have to start with the point. Even if you're given a slope, somewhere you've got to find a point. At some case, you've got to find a point. So I'm going to graph the point first. So I'm going to go over 8. 1, 2, 3, 4, 5, 6, 7. And down 2. Okay? Now what do I do? Okay, I draw a horizontal line. What does a horizontal line look like? Somebody else different. Yes. It's flat. Horizontal line's flat. So I'm going to draw a horizontal line. Where? Across that point, right? That's why they give you the point. Just making sure that we're good. Okay, so there's my horizontal line. So that's the graph. Now let's answer a couple questions about this. What's my slope, Princeton? Okay, help him out, Kaylee. 0. How do you know that, Haley? Go ahead.
Because it's the line is like a 0. It's just a straight line.
There's no y value. That's okay. There's an easy answer for this.
Slope dude.
Okay, slope dude helps you remember that horizontal lines are 0.
It's flat. It won't go up.
I mean, you could think about like that. Here's the deal. If I'm standing on this ground, the ground is flat, right? Mm-hmm. Okay, well let's take another example. If I take a basketball and I set it on the ground, where's it going to go? Nowhere, because the slope is 0, right? It's 0. Since the slope is 0, it's not going to go anywhere. But I can set it there because I can set it on that. That means I have a slope. It just happens to be 0. The easiest way to say, hey, I know that slope is 0 for a horizontal line is because I memorize it. All horizontal lines have a slope of 0. Okay, all horizontal lines have a slope of 0. Okay? What's our y-intercept? Okay, -2. Emily, what's the equation?
Y equals -2.
Y equals -2. Okay? So horizontal line, every horizontal line, and you might write this in your notes. Every horizontal line has the equation of y equals some value. Okay? And what I mean by some value, that's some number. There's no x, there's no other variable. Okay? So horizontal line has no x in the equation. So every horizontal line has an equation of y equals some value, like y equals 5. In this case, y equals -2, y equals 15. And every horizontal line has no x value in the equation. Okay? When I throw an x value in the equation, what have I created? What? Not a vertical line. I've created a slope of some sort, right? If the x comes in there, that slope is that number that's where? Beside the x, right? If I have an x, even if I have just an x, I have a number what? 1, right? It's understood 1. So if I put an x there, my slope becomes 1. So if anytime I throw in that x, I end up with the slope. Now we're going to get to the vertical line in just a second. Okay, any questions about this?
What about the line that crosses the origin?
Depends on which way it goes, right?
No, I meant like if it's a horizontal line on X and Y.
Yeah, that's what I'm saying. Depends on which direction it goes. Watch. So let's say, so Nathan brings up a good question. He said, what about the line right here? I'm going to put it just barely on top so that we can see it a little better. Oops, wow. Wasn't paying attention. Okay, so he's saying, what about this line here? What's the equation for this line? Yeah, this is y equals 0, right? Why is it not x equals 0? It's not vertical. But if it was vertical going through the 0, it would be x equals 0. Make a difference? I understand? So y is for horizontal, which is kind of weird, right? Because what's our x-axis? So we're horizontal, so it's kind of flip-flopped, right? Okay. And x is for vertical, right? Okay, and we're going to talk more about that here in a second. Okay? Going back to the green line for a second, which is this one for if you can't see very well with that green line. Okay, what is our domain? Okay, Jefferson said all real numbers. Why do you say that? Why does he say that, Rhiannon? Rhiannon. Why do you think it's all real numbers? Talked about this a little bit yesterday. Okay, help him out, Gracia. Okay, and she said it right. She said the line keeps on going both ways, taking up all of our what? What numbers? What does domain deal with? Not real numbers, but x values. Takes up all of our x values, right? Because again, when I'm looking for domain and range, I'm always trying to find a minimum and a maximum. Can I find a minimum on the x-axis? No, because like Gracia said, it's going to keep going forever. Okay, so that's okay. So let's check, see if I can find a maximum. Can I find a maximum? No, because it's going to keep going forever. So if you're never going to find a minimum or a maximum, it's all real numbers. For domain, it's all real numbers. But what's our range now? Okay, range is simply -2. Because there is only how many y values? 1. The only y value here is -2. Now here it is. You're going to have an infinite amount of times, right? This is -2, 2, 3, 2, 9, 2, -6, 2. You're going to have that 2 a whole bunch of times, but the only y value it uses is -2. Does everybody see that? Yeah, okay. All right, let's look at our next example. It would be logical, right? What's wrong? Do you need that?
Yeah, what is in that? No,
All real number symbol. Talked about it yesterday. No? Okay. All right, here you go. Let's go ahead and we're going to graph a vertical line through -5, 4. So vertical through, what did I say, 5, 4? -5, 4. Okay? My first step is what, Caitlin?
You're going to graph, right?
Graph what?
-5, 4.
Yeah, first thing is to go ahead and put a point on -5 over and up 4. Okay. What do I do now, JC?
Draw the line.
Yeah, now I'm going to draw the line. Okay, which way is it going to go? Vertical, right? Through this point. Here's my graph. Let's go ahead and identify some things. Riley, what is my slope here?
Zero.
Not 0. Undefined, right? So we can write it like this. Okay, how do I know it's undefined?
Yeah, that's.
And you know what? You guys that keep saying, I just thought slope, dude, that's great. That's exactly the point. That is absolutely why we do that activity. Is because now, and realistically, positive and negative is pretty simple. Once you get the hang of positive and negative, you see those more often than you see vertical and horizontal, that's fine. But you guys thinking of the slope, dude, that's exactly fine. That's why we do the activity. Okay? But what do you know about every vertical line, Braley? They all have a slope of what? Undefined. Again, goes back to memorizing the fact that every slope of a vertical line is undefined. And again, that's part of the slope dude. If you say, well, I figured that, I looked at the slope dude and that reminded me of that. That's perfect. Okay, that's absolutely okay.
I have a question.
Yes.
How do you know if it's gonna keep on going or if it's gonna make a cut?
Okay. In these cases, it's telling, when it says line, it'll tell you a line goes on forever. And this is more of a geometric idea. We deal more with lines in algebra than we do rays and segments. Rays have an endpoint that go on one direction forever. Then you have a segment that has 2 endpoints. Okay, so when it tells you to graph a line, that means it's going to go on forever. Okay? Okay, what is the y-intercept? Zach. Okay, it's not 0. Okay, what's the y-intercept, Sierra?
4.
No. What's the y-intercept, Reagan?
Is it no the y is
Yeah.
negative 5?
No, y'all are guessing. Okay, what's the y-intercept, Kira? Some of you have caught, not caught, as in you're in trouble. I caught you not paying attention, which is why you're messed up right now. Kira, what's the y-intercept?
I thought it was 4.
Okay. What is 4? Well, there's nothing is 4. Okay. What's the y-intercept? I know you're silent, but go ahead and tell me what the y-intercept is. Okay, what's y-intercept? There is none. Does it ever cross the y-axis? Okay, look. Y-intercept, it's you got to remember the definition, vocabulary. You have a vocabulary quiz tomorrow. Okay, the vocab words are on Blackboard, so you better start memorizing those. Vocab quiz tomorrow. The y-intercept is where the graph crosses the y-axis. Where is this graph crossing the y-axis? It doesn't. Okay? What is -4? Or, I'm sorry, what is -5? The x-intercept, right? -5 is the x-intercept. I don't know why. I guess because we were looking at this y value.
Yeah.
That's what's throwing people off. But that has nothing to do with the y-intercept. Okay? Memorize your vocabulary. So there is none. That's what I'm going to write. None. Okay, what's the equation of this line? Where are we at here? Nathan.
X equals -5.
Yeah, x equals -5. How do we know that, Nick Mueller?
Because the x is the line goes through negative.
Yeah, I mean, and as simple as that sounds, and it's not mathematically fancy like, well, I solve for the slope, and then I solve for the b, and then I put them into slope-intercept form. It's not mathematically fancy. It's just simply, well, the line goes through -5 on the x-axis. It's the only x value that it goes through, so it's got to be x equals -5. And I've memorized the fact that, just like the y, but opposite, go ahead and do it again if you haven't, all vertical lines have the equation x equals some value. And again, x equals some value, meaning x equals a number like 4, or in this case, x equals -5. Okay, so it's x equals the only value being used on the x-axis. What is missing from this equation? Nope. What was missing in the horizontal equation? The x was not there, right? So what's missing in this one? The y. So the y is not there. So these are basically opposites of each other. There is no y in the equation. Now, does that make sense? Yeah, why does it make sense? Because it doesn't cross or it doesn't have a y-intercept. So the fact that there is no y in the equation actually makes sense because there is no y-intercept. Okay? All right, now let's look at the domain of range, since some of you were so eagerly asking for it. We don't have it. Where is it? What's the domain? Again, what does the domain deal with as we prepare for a vocabulary, Nick?
The domain is what we asked.
Yeah. What is it? Yeah, basically definition.
Um,
All of the what?
all the x-axis.
Yeah, all the now x-axis. That's a big common mistake. X values. It's all the x values being used in a function. Okay, you don't want to say all the x-axis because that's everything. You don't want to say all the x values because that's everything. You want to say all the x values in a function. Okay, because in some cases we don't use them all. Okay, so Angelica, what's our domain here? Rub your lip. Is there any other x values? So -5 is the only one because look, when I go to my x-axis, the only x value being used is -5. Here it is. It's all blank. Okay, all -5. Now every y value has the same x value, and that is what? Every y value has the exact same x value, which is what? -5. Remember how we talked earlier in the year about functions? How do I know if something is a function or not? It passed the vertical line test. That was one way. What else? Somebody else. If the x values repeat, then it is not a function, right? So we talked about vertical lines earlier in the year, and we said, hey, we said this is not a function because it doesn't pass VLT. That's what we talked about a lot, because every point hits that. But now you can kind of see that, well, every x value repeats, doesn't it? -5 and 3, -5 and 2, -5 and 4, and so on and so on. All the x values repeat, so that's why it's not a function also. Okay, so we are to Ruby. What's the range? Well, first tell me what the range deals with. It's all the y values in a function or an equation. In a function, that's better. So what is the range then? All real numbers. Remember, if we're looking at vertical and horizontal as being opposite of each other, the domain for the horizontal was what? For horizontal, the domain was what? All real numbers. Now we have a number for domain, so the range must be all real numbers for this if we're thinking in terms of being opposite of each other. So there's our all real numbers. Okay? Any questions on this? Okay. That's all we're going to cover for this.